I guess let's get started. So today we'll be doing this question called minimum size subarray sum, right? So basically we are given an array of positive integers and we are told that we need to we are also given a target sum over here, right? So what we need to eventually do is that we need to return the minimum length of the subarray, right? Whose sum is actually greater than equal to the target itself, right? So let's get started and let's understand how we can actually approach this problem. So eventually let's say that if this is a nums, right? What we can eventually do is that think about this, right? I'll try to give you an example and try to explain you in a very quick manner. So let's say that we have an elements like these, right? And let's say that the target itself was 5 over here, right? Now let's just forget about the question and let's just first understand that what could be the targeted subarrays. So the first subarrays is this simple one, right? Right? Because 2 plus 3 is 5. And the next subarray itself is this one, right? Nothing fancy, just a straightforward things, right? So eventually the minimum length subarray will be 5 itself over here, and that is the exact answer which we need to return, right? So once we have found this, right, we need to just return the answer. That's all. But how do we take care of this? How do we eventually take care of this, right? And let's try to further take some examples, right? Let's see. Uh, I can take an example of 4. So let's say that the target was itself 4 over here, right? So eventually we could reach something like this. And you could try to understand that this first element itself could be the answer, right? But later when we try to expand, we could also encounter this particular part, right? 2 comma 2, because this eventually equals to 4 over here. And we could also encounter this subarray, right? Because this is also another, which is just greater than equal to the target itself over here, right? So right now I'm just taking a very basic example so that you can get an idea. But eventually what I want to share with you is that we are dealing with something called windows over here, right? That's the first hint which you can eventually get, right? Forget about the fact that how we are going to approach this problem. But the very first visualization which you must have gotten is that there is something called windows over here, right? The window can shrink and window can squeeze, right? That is, it can expand or it can shrink, right? That's what I was trying to convey. So these are the only two options of the windows, right? But the problem over here is that how do we control the shrinking and expanding of the window, right? So let's say that we denote the start of the window and let's call it start, right? And let's say that the start of the window was at 0 itself, index 0, right? And we have another index of end equal to 0, right? I'll try to explain you what is exactly happening over here. So when we first try to begin, we have not included any element because we can have a very corner case over here that the very first element in the window which we are trying to include can be greater than equal to the target itself. And we have to consider that, right? We have to consider that. That's why we need to say that the start and the end of the window itself at the 0th index, right? Okay. Now, once we have declared this thing, what we can do is that since the start of the window it itself can be contain the element which is greater than equal to target, we need to handle this case specifically, right? So then we say that, okay, I am going to shrink my window. But hey, we just try to include one element and you are already saying that we are trying to include like shrink this window, right? So I will repeat what I just said, right? So initially the sum of the window at this point the sum of the window when the start is equal to 0 and the end equal to 0 is 4, right? Because we just included an element over here, right? And what has eventually happened is that consider this start and the end is the same position, okay? And the sum is equal to 4. But now we have exceeded the length, right? Any further element which we try to include makes no sense for our answer. That means we need to shrink it. So it basically means that we need to update a start which was over here to start plus 1, right? So eventually we could only do this and we will be very much satisfied, right? Because now we will be starting the window from start plus 1 itself, right? So that's it. But what are the conditions until we keep incrementing a start, right? So think about this. There can be different conditions. For example, let's say that our target is, let's say, 15, right? And it is something 9, 8, 9 plus 8, 16. and this is 16 plus 3. Let's try to include some arbitrary elements, right? I'm just going to show for some few example more. So right now we try to include both these elements, right? Once we first try to expand this window, at the initial phase, start and end was at the same index, right? So again, the start and end, since that they were at the same index, the sum would be 9. And when we try to expand it, 9 plus 8, this would eventually become what, 17, right? And at this point, we need to shrink a window. We need to shrink a window. So what we'll do is that we will start shrinking a value from the left hand side, right? And then what will be the sum at this point? 9 plus 8 minus 9, that is eventually equal to 8. And that's when we know that we stop it. We stop from here itself, right? So this is what I wanted to convey to you guys, right? And this is the entire concept which we are eventually going to use over here. So the for the folks who are doing the two pointers, right? So this question involves the concept of two pointers as well as the sliding window. And the reason I wanted to stress on the start is equal to 0 and end is equal to 0, because there are high chances that you can mess this concept during your interview itself. Why? Because what can eventually happen is that you might think that, oh, usually when you do a two pointers question, you always take start to be somewhere in the extreme, right? Start is somewhere on the zeroth side and end is actually equal to next element, right? So this gives you an idea of a two pointers, right? Because now we have two pointers, which is again, the both are at this some different indexes, right? But what might eventually happen is that you might miss including the fact that the first element itself can cause a problem. And this is what our actually problem is over here, right? So that is something which you need to account for. And the second thing people actually confuse over here is that how do you do the indexing and how do you calculate the length? So for example, people sometimes use this formula like min length is equal to end minus start. This is end actually, guys. End minus start plus 1, right? And we also take the minimum length over here. That's it. So this is how we define the minimum length for this thing. And we have n minus start plus 1 and we have minimum length over here, right? So eventually the start and end, let's say that we are at the first position itself, the start and the end will be 0, 0. So 0 minus 0 plus 1. And eventually we will return the length as 1 itself over here, right? So this is how we're going to handle it. So do not confuse it for the end minus start, right? This would just become incorrect, because if you do the end, if you just subtract the indexes, it will not give you the correct length, right? If you subtract 0 minus 0, it will not give you 1 length, which you will need to get over here. So these are some common things which you need to take care during the interview, and there are very high chances you can mess it up. And the final thing which I want to share with you guys is that you need to handle the case where if there is no such sub array, then you need to return 0 itself over here, right? If there is no such sub array, you need to return 0. So that means we need to handle the case of this as well. So I will just start coding this thing, and n is equal to this, and okay, we can have this over here itself, and there is no is equal to 0 and less than nums of. And at this point, we are going to try to include the element start over here, or we can have the end itself over here, right? Because eventually the number which we are trying to enter is end over here, right? We are not trying to enter the start itself. So that is one thing. And if while sum is greater than equal to target, we need to update our length to handle this thing end minus start, and we just need to return a, and then we can decrement the sum, because as we are moving ahead, right, we remember this thing, as we are moving ahead we need to decrement the value from the sum itself over here. So let's decrement the value, and let's actually it's start end, and let's try to, right? So with all of this we need to return if min length is equal to int mass. So if min length is actually equal to int max, then we can say we can return 0. Otherwise, what we can do is that we can return the minimum length itself. So what I have eventually done is that, right, we are storing the sum over here, we are storing the start, and we are storing the min length over here, right? And at the end, we are just adding the elements over here, right? Initially, we have initialized the sum to 0 itself, right? And as we go ahead, if the first element itself is equal to the answer itself, then we are going to store in a min length. But at the same time, we know that this is not a true answer. So what we are eventually going to do is that we are going to go ahead and we are going to increment a start pointer at this point. Okay. So, yep, if we try to run this thing, let's say, so this given loop will run until the sum is greater than equal to target itself, right? Once the sum becomes less than target, this loop will stop and this will not run anymore. So I hope you enjoyed the video, and I think so that's it. Thank you.